Hello everyone. My name is Muhammad Umar Hayat, um, and today I'm going to talk about the billion node graph neural network in PostgreSQL. Um, so first, my introduction. I'm a software engineer, and right now I'm working as a lead developer in Engent. It's a South Korean-based what we call a database company. And personally, my interests are in PostgreSQL. It's almost more than 10 years I'm working in PostgreSQL in different database, PG-based database companies. And I work on the PostgreSQL as well as on different Postgres-based graph database and HA tools, especially in PG Pool. And basically, I'm from Pakistan and currently living in South Korea. So today's agenda is first I will introduce about the graph neural network GNN, and then how the pipeline the data pipeline works, um, and then I will just talk about different GNN algorithms and then different implementations, especially implementation in link, combining the implementation of GNN with the PostgreSQL ecosystem. So the first part is the introduction, and before introducing the graph neural network, last year I had a talk in the House 2025, and back then I talk about different graph databases or graph tools or extensions available in PostgreSQL ecosystem. So there is a little update from last year till now that in last year. Um, I talk about three different, mainly the streams, different communities, sub communities of PostgreSQL are working. One is Agents Graph, the other one is Apache AGE, and the last one was the PostgreSQL community, which is implementing ISO PGQ. So the first one is Agents Graph, was the first time released in 2017. It's a PostgreSQL based fork. And there are three releases last year in 2020. That is incorrect. That is 2025 last year. And currently, the latest release is based on PostgreSQL 16. And the other community related to Graph is based on Apache Foundation, which is Apache AGE. It is based on the code base is similar to Agents Graph, and the development team was similar. The same for AGE initially, and it was first released in 2022 as a top what we call a top project in Apache Foundation, top level project. And the latest release is compatible. It's an extension and it is compatible with the PostgreSQL 18, the 1.7 release. And the last one is the PostgreSQL community itself. It is also developing graph features implementation, and which is the standard inside ISO is the ISO PGQ. The first release, hopefully, it is already committed in PG19 code base. So hopefully it would release in PG19 this year, and of course it has basic feature as compared to the prior different PG based graph solutions, but it has it need to of course improve further in coming year, and the development different PG hackers are already working on the more features that need to be coming in the PG20 and onward. So that was about the graph update on the graph. So similar to continue the same the graph, um, graph topic. This year I'm planning to talk about this graph neural networks. which is recently a lot of companies and are working on these graph neural networks. So what exactly it is? So if you compare it with the traditional neural network, which is mostly focused on the data points and isolated data points, with the GNN graph neural network is mostly give more important to the connectivity as well. And how it actually works, it also, like the other the neural networks, is pass the information to different nodes in different layers, and then information is aggregated, and then and using the different graph neighbors, neighbor nodes, and then it is shared with the next layer, and then it goes on. So having this the graph connectivity, it provide the context, and so there are of course a lot of benefit to use this graph neural network, and it provide a lot high accuracy for link prediction and node classification, and then you can make use of these graph neural network algorithm for um, different industries, different implementation. So, what is the real world benefit? Of course, right now, it is used in different industries, especially in the finance, for the fraud detection and money laundering detection, or the fishy kind of transaction detection and actors detection, how they are linked together. So this is very the big area where this GNN algorithms are used. Of course, the other area is chemistry, where it is used for the molecular modeling, and of course, you can use with the social media to predict different links and recommendation based on different the data set which is available, and it is modeled as a graph. So only these are not the only three possible areas. Of course, there are a lot of them. These are the more prominent one. Especially in my last few years, I mostly work with the first one, finance one. There is a lot of usage for this one. Next one is the data pipeline. How actually, I mean, before reaching to how actually we actually implement and use the graph neural network, there are few steps before. We have to prepare that environment, and that's a typical environment for most of the analytical systems, not only the graph neural network, but in general other one as well. So like normal OLAP use cases, there is a typical ETL pipeline. You extract the data, you transform the data, map the data into different a new form, which is more convenient for the analytical algorithm. So similarly for this one, graph neural network, or in general other, not only the neural networks, normal graph algorithm which are available, when you implement them, you have to go through these steps. So first, you have to extract the data. Either it should be from the RDB tables, relational tables. Then you do apply some transformations, and then you represent them in a graph database. Now, of course, it depends on which kind of graph solution you are using. I mean, right now there's agents graph. Whether you are agents graph also is a multi-model, so you can store your RDB data inside there and then do some transformation, and then of course store back again in agents graph, but in a little bit different format. Similarly, AGE is extension. If you have the data inside the PostgreSQL, you have to transform it and make some like a graph schema, and then store back in the same database, but in a different, more graph-friendly model. Similarly, if you have the recently, which is committed ISO PGQ, it's still same. You already have the different RDB tables. And then you can use different graph queries like create graph, and you can tell, okay, this table has the entities or the nodes, this the other table, it has the edges information. And so that's how you model them. So normally you have three options. Like you either, I mean, currently the open source option based on PostgreSQL, you have the agents graph as a graph representation, or you have a graph store as a graph in PostgreSQL using Apache AGE, or you can use, yes, keep them as PostgreSQL, RDB tables. Eventually, all of them are RDB table in PostgreSQL, but the representation, logical representation, it matter a lot. So before going into the different graph neural networks algorithm, there are a lot of time people get stuck and on the first step, this the data loading pipeline. Because I mean, I'm not talking about a small number of few thousand records. I'm talking about the million and billion of records. Okay, and then the interconnection between them. If you have million of nodes or billion of nodes, how many edges they would have in between them. So how would you map from RDB? How would you transform them, and how would you load them? And especially the edge creation, like the normal, the label creation, you might be just copying just one, the whole table or a number of column into a new table. And but once you create them and you want to do some transformation, and then you have to create the relationship between them, and you might need to modify the existing relationship table. And that complexity could be it's not linear, then it's quadratic complexity. And with that big database, it may be taking few hours to load just the data. Okay. So we are not talking about the millisecond or few minutes. I mean, it could take, if you are not properly doing it, it can take, a few hours to just load data only one time. And if you have to do it again and again, that's, a lot of overhead, even before running different graph neural networks. Most of the time, what we recommend and what I see is that you need to know the environment, different parameter. There, of course, there are different parameters for the SQL table, as well as there are parameters and configuration variables available in agents graph, and even a few of them are available in Apache AGE as well. So before, you need to understand, what if there are some indexes and you are repeatedly running different queries and loading the data, whether you should pass different indexes, stop them, disable them, or what you can do is, how can, is it possible to directly map a PostgreSQL table into a graph table? Most of the time, agents graph and AGE does not allow it, because somebody who does not have that much information, he can disturb the whole schema and the how agents graph and AGE works, because they actually map the original primary keys to their own IDs, the graph IDs based on the label IDs, and then using those IDs to create the edge IDs between different nodes. So normally this is disabled, and but you can, I mean, if you have spent some time and you feel that disabling some index, or disabling some just mapping some original primary key with a numeric, like the sequence based number in as a label ID, you can do it, but you have to enable these cipher allow unsafe DDL parameter, then you would be able to do it. Also, there it has a different like the PostgreSQL normal statistics. It also have the graph metadata statistics. So if you are loading the data in batches, or in in multiple transaction, you should disable it, to save some a lot of time. And after the loading this data, you should do few things like that auto gather data is disabled, but you can recalculate those statistics using different functions. One of the function is like regather graph metadata. So using regather graph meta, it will populate all the statistics about how many, if there is a label, how many edges this label has, the connection with the different other nodes, and this will be very useful to speed up the query planning and execution time. It can use these statistics to improve, like for example, if it already know there is no edge for a specific label, it will not even go to the edge table to even scan it or find out whether it has it or not. It will just use the metadata and plan the query accordingly. Similarly, agents graph by default in AGE, by default, they do create the indexes. So in PostgreSQL, if they are not, we should create the indexes for them, for the especially the edges. You will see these the different algorithm for the graph neural network. They use a lot of this edges information, and so this is one way. Another one is that because you would be again and again querying different labels to find their edges. So it's better to cluster. If it is a static data, then it's better to cluster it using cluster SQL cluster command in PostgreSQL. Cluster the table based on the index so that it can group the data or realign the data based on the index. So it would be more easier to find the related data, at the in vicinity and on the single place. Not a single place, of course, it can span multiple pages. So this is before, just a few tips for the database loading, the graph data loading. Another now on the GNN algorithm, there are a lot of algorithm. I'm not going to go to all the algorithm which are available for the GNN. There are few which I will be mentioning here. Most prominent ones are the one which the further down the line for the implementation, these algorithm will be mentioned in our PostgreSQL ecosystem. So there are three of them which I mentioned, which is one is the graph SAG sample and aggregation, the graph convolution networks, and the graph attention network. So these are the three major kind of algorithm which is mostly used by data engineers. There are different graph spin. I guess I don't know. I don't remember the name. There are a lot of other algorithm as well which are available. So for different, all of them, like the learning type, this slide is mostly showing how the data engineers see these algorithms, like learning type is inductive or transductive or is a partial, what is the accuracy of these algorithms, with which one has a high accuracy, it's just enough for some use cases, or sometimes you need very high accuracy. So the GAT has the highest accuracy, and the same is the complexity. If you see the GAT, it has the inductive, very high accuracy. Its implementation is also complex, and real-time inference is quite impractical. And same is for the query complexities as well. And on the other hand, the very the easy part, or accuracy is of course is good, high, and complexity is medium for the graph stage, and the inference is practically possible even with the graph, the large graphs, and the query complexity is also very low. On If we see the same algorithm, three kind of algorithm in the on the database side, database perspective, how these algorithm will use, or how our application which we will develop our algorithm, how they will interact with the database. So if you see the graph sage has it use the it does not use all the neighbors. It can pick different samples and then work with run the different aggregate or other operations, GNN operation on them. But for the GCN, and it need full neighbors. If there is one label, it will get the information of all the neighbors and then do the same, aggregation and other mathematical formulas, neural network formulas on them. And then the GAT is more complex, full plus attention. On the other side, what is how the language is friendly? Like for the graph stage is more SQL and Cipher friendly, while GCN is a medium, and the GAT is very low. The same for the AGE and agents graph. Compatibility for graph stage is more compatible. Why? Because agents graph AGE, both of them they support Cipher. Uh, Even for the plain SQL tables in PostgreSQL, you can use them. The I/O overhead, if you see for the graph stage, is low because it does not scan all the nodes, not even not only on the first hop, but not on the the next level hop as well, the neighbor as well. So its I/O is overhead is limited and low to medium, while the GCN is high and GAT is quite higher. And you can use mini bats in the GC Sage, Graph Sage, but not the. It's a bit difficult for them, and it's easier to scale the this Graph Sage as compared to the GCN and GAN. Now, normally how graph sage sample and aggregation works is normally you have a graph input, of course, graph, and then you have a target node, and then it has neighbors. So in the graph sage, it means you can pick a sample, and of course, depending on different algorithm, you can select, depend how you implement that algorithm, that it should cover 20% sample, it should cover 20% sample, 50% samples, pick the randomly, or sequentially, or in which way it should pick the neighbors. And the neighbors which are on the first hop, immediate neighbors, or on the second hop, the next neighbor, neighbor of neighbors. So you can use different sampling and hops for different sampling for the neighborhood sampling for the graph sage, and based on these ones you implement different mean LCM, or like different aggregate function by on the different feature you collect from the neighbors, and then you generate final the output. And of course on the multiple layer you continue this operation multiple time on different layers. So you have the input graph, you sample the graph, then you apply the aggregate feature, then generate some embedding, and then use those embedding result to classify different, different kind of graphs and entities. On the implementation side, I mean, I'm mostly because if in the previous slide we see that the graph sage is more suitable for these databases, and it's easier to implement as well, and more suitable. So we would more discuss on the graph sage, the different implementation we would discuss. So the first implementation would be that I mean, how I design this, the topic is, one implementation is where the total, everything is, the algorithm is running only on the client side, and we are getting only the data. Data is stored on the server side, which is Agents Graph or Agents SQL, Agents Graph or PostgreSQL, or on top of that, there could be Apache AGE. So the fast implementation is this, that you have, this is traditional, most of the data engineers use this mechanism, and you get, you run different queries, you write a Python script or an application. It has nothing, it's totally isolated from the server, and then you can connect using different drivers like psychopg driver in for PostgreSQL. That driver is available both for PostgreSQL and Agents Graph as well, and AGE as well. So you get the use the driver, query different data sets, and using those queries to sample the data and get the neighbors, and then extract and transform and apply different your own neural networks, operations. Now, this is if you want to visualize it, it would be like that. You have a Python client and you have a server, and for neighborhood sampling, as well as, of course, you need their feature as well to run different functions. So you would be using the same cipher queries or the SQL queries to get the neighbors list as well as the feature as well, and then you transform them, and in the CPU or GPU you run different computation, and then you that's how you train your the model, and then you save your result back into the database. So the good thing about this is it is easy to develop, and most of the database data engineer use this approach. And you have all kind of libraries, learning libraries available, and you can use them. And of course, there are different libraries which even scale on the multiple machine as well, and they can utilize the GPUs as well. And so all those things are possible using this approach. The With the large graphs, the problem is that the network bottleneck, because you have too much data which is moving from server to the client, client to server, and you have to fetch the neighbors, you have to fetch the features, you have to then do the calculation on the machine, and then go back and get the next level. And that's a lot of data which is moving, and it's very difficult and quite challenging to implement this kind of algorithm or application for the real time inference. The next one, another better approach in a way, I mean, we will see how it is better, is that you implement the graph sage algorithm in as a PL Python extension for PostgreSQL or agents graph. And of course, still you would be writing the code in Python, but in user defined functions, and they would be still inside the DB. And the PyTorch, or the PyTorch geometry, or DGL, deep graph learning, both of these kind of libraries you can install as a environment, the Python environment in the database server, and you can use the same kind of all those computational libraries using PL Python. And of course, instead of getting the data from a remote server, you would be just triggering different functions to query the data and to use it from the the local RAM of the server memory to and do some computation and uh, uh, graph neural network computation. So this is kind of how it looks like. I mean, from the client side, it's very minimal. You just send one query, a function which is written directly on the server using some CLI, and everything is inside the function. The how it is implemented is inside the database as a function. You are running the computation there on the server side, and then just saving the result on the same server, or maybe you would be returning it the result for some other application. So of course now it removed the data moving thing. That latency is now gone. So it is a bit simplified pipeline. The more the bad thing is, like, now there would be a resource contention, that how would you manage between the normal OLTP, the traffic, and this long running queries for the GNS. And of course, inside the managing the Python environment inside database server is a bit challenging. The last one is very performance wise. Of course, it can provide maximum performance with a low level integration of writing all those graph sage algorithm in C inside the C function, or C or C++ function. So neighbor sampling, feature aggregation, neural networks, mathematical function, all of them you can write as the PostgreSQL user defined function, and you can use them. So you can directly access the memory or the pages, whatever you want to access. And so it now, even with the Python, when you use PL Python, it still do the serialization between C storage to the Python one, even especially for the JSON data type, which is used by property for storing the properties in the nodes. Of course, this serialization, the JSON dump and load, it takes time. Okay, and also the query execution overhead is gone. So now you can you can access the data from the memory and the disk as well. So this is how it looks like. Everything is compiled in C, and you can access the full, the whole native layer of the database. And the good thing is, of course, it has you minimize the memory overhead, and also this is the maximum speed you can get. There is no data serialization as well, so highly optimized and low latency for the graph neural network task. The disadvantage or con is like, it, of course, you need to understand how the PostgreSQL extension works, how they are built, how, so there's a, steep learning curve over there. So of course, maybe a lot of libraries provide, built-in different functions for this task, which maybe you need to rewrite in the C++. And of course, if there are some issue with those functions which you have written, it's not easy to debug as well in this environment. So these are the different. The summary is, of course, more suitable option is to use the graph sage in the billion node graphs with the neighbor sampling. More flexible way is using Python for the network bound. For the PL Python can reduce the latency, and the maximum is uh, so the maximum performance you can get is with the C implementation, but that would be have a more learning curve there you have to tackle. So the summary, the result is that you can use billion nodes, multi-billion nodes, edges, and labels inside PostgreSQL ecosystem, and you can run your the GNN algorithm. The last thing is, this is not the only way, of course. There are multiple ways to optimize this, this how you implement graph neural network in PostgreSQL system. This is, few ways I mentioned and what I experienced in last few years in the PostgreSQL ecosystem, especially in the graph side. So this is it for today. And if you have any question, feel free to reach me out on different, on the LinkedIn or GitHub, or directly on the email. And hope you enjoy this conference. And apologies for that I cannot join the meeting, this conference in person. And thank you, everyone. Have a good day.